My name is Susan Lechelt. I'm a lecturer at the University of Edinburgh, and today, on behalf of my co-authors, I'll be presenting our work entitled From VizBlocks to the Data-Driven Actor, Reimagining an Open-Ended Data Physicalisation Prototype with a Creative Business. Before starting, I'd really like to acknowledge the range of individuals who are involved in this work from across our three organizations, including Pip Thornton, who was really the driver of the collaboration represented in this presentation, and the range of students and research assistants who contributed to development work, as well as our funders. So in this work, we explore the question, how might the prototypes that we create in our design research as academics be enabled to take on a life of their own beyond just planned research activities? And further, what might be the potential for our design prototypes to inspire and support the work of local businesses or communities? The starting point of this work is a design prototype called VizBlocks, which was designed by my colleagues at Edinburgh and TU Delft. And VizBlocks is a physical computing toolkit that's made up of modular blocks that are embedded with actuators, including motors and LED lights, which are used to create physical representations of data. VizBlocks has the goal of lowering the barrier to creating physical data representations without requiring a lot of programming knowledge, and it does this by enabling users to connect live and online data sets to the physical VizBlocks through a low-code visual programming interface called Node-RED. The VizBlocks are designed to be really open-ended and ambiguous, and in this way, they seek to enable kind of a range of data sets to be used as an input, and for this data to be represented in a range of ways using the physical actuators as an output. The way VizBlocks is aimed to work in practice is that the blocks can be attached to a wall, such as the one pictured, to create what we call data sculptures. And the blocks can be physically augmented with a range of materials like feathers, balloons, cocktail umbrellas, and others, which add a sort of additional dimension to the embedded actuators. The VizBlocks are then programmed by the user through the Node-RED interface so that they move and react based on live and online data sets. So after creating VizBlocks, we were introduced by a colleague to Civic Digits, which is a small creative theatre company in Edinburgh who work to engage children and young people with science, technology, engineering, and maths through using performance and theatre. Civic Digits were interested in seeing if there might be opportunities to collaborate with us on exploring how new technologies might fit into their practice. And at the time, they were developing an accredited course for 12 to 14-year-old school students that would enable them to think critically about how data impacts their lives, but also help them experiment with data in creative ways. So we gave Civic Digits a tour of our design studio, and as a part of that, we introduced them to VizBlocks. After the studio walkthrough, Civic Digits came up with the idea that VizBlocks could actually be used to build a sort of digital actor, which they called a motorized emoji at the time, that could express various emotions based on the data sets that were run through it. So together we engaged in a co-design process, and our goal was to adapt VizBlocks into this data-driven actor concept. We ultimately decided that the face would be made up of 5 motor and LED light VizBlocks, which represented the eyebrows, the eyes, and the mouth of the actor, which you see our very first prototype of here. We also developed a youth-friendly interface to make setting of the behaviors for each block even easier. So through this interface, the students would be able to use sliders and drop-down menus to set behaviors for individual VizBlocks. So for example, setting LED light colors and motor angles. So a very simple way of controlling the behaviors of the VizBlocks. Alongside the app, we also developed 2 proof-of-concept prototypes to demonstrate how the data-driven actor might react based on various forms of data. The video you see here demonstrates using live facial expression data to control the data-driven actor. So specifically, an algorithm used with a camera recognizes whether a person is smiling or frowning, and then this controls the physical response. Our other proof of concept application was to use weather data sets over time to show sort of more complex dimensions of data sets, for example, temporal changes in data. So, for example, in Scotland, where we're based, where it tends to be very dark and cold, perhaps given a data set of weather throughout the year, the data-driven actor might be mostly frowning with a few smiles here and there, but in other climates, it might be a bit happier. Once it was developed into a fidelity that was appropriate for classroom settings, Civic Digits then developed a workshop around the data-driven actor that would be run in schools, which weave together the technology alongside discussion and craft and performance-based activities. So just very briefly, I'll summarize what the workshop involved. After an icebreaker, the students were presented with a demo of the facial expression setting that you saw in the previous video clip. The individual VizBlocks, which were the facial features, were then distributed throughout the classroom to smaller groups, and the students were asked to personalize them with craft materials and then program them through the app interface as well. The parts were then all brought together again, and the students were given a demo of the weather data set setting, really as a way into discussing more complex data sets. And finally, the students were asked to design character personas for the data-driven actor and to create stories for their characters, so including thinking about what other data sets could be used to represent those stories. In terms of success and impact, the work really enabled Civic Digits to shift their business model from mainly offering performance experiences to now also offering a tangible product that can be sent to schools as a package. And a wonderful outcome is that the data-driven actor has now been used with over 2,600 school children all over the UK. So the collaboration has really supported the offering of local business while enabling the academic prototype to also have a wider reach. In the rest of the time, I'll reflect on our collaboration in practice, as well as how the specific affordances of VizBlocks enabled the configuration of how it was reimagined. So first, I'd like to reflect on our collaboration. Our collaboration was at first really open-ended, and we were all really excited about the prospect of working together, but we didn't really have a set process or allocation of labor in place. And as the project progressed, there was a lot of work to be done to make the idea of the data-driven actor a reality, especially to a level that would be suitable for use in classrooms. So this included, of course, developing the interface that the students would be able to interact with, the facial expression and recognition, as well as making adaptations to the blocks themselves to be a bit more fit for purpose. And this involved about 3 months of full-time work from our research software engineer, Evan Morgan, as well as a consultancy from creative technologist Fabio Fidanza. Civic Digits also put lots of work and effort into learning how to use the VizBlocks system. So, for example, for founder and artistic director Clare Duffy, it was her first time working with physical computing interfaces, and she had to put a lot of time and effort into learning the fundamentals of coding microcontrollers, as well as then the particulars of VizBlocks itself. And on the university side, we also spent time supporting Civic Digits learning, for example, writing expanded documentation for them to be able to use it themselves. What was really key to making all of this work was that the people in our team were very willing to take on time-consuming and difficult tasks, but we also did have to find additional funding to give us the time and the space to do all of this. Next, I'd like to reflect on what factors actually enabled VizBlocks to be reimagined in this way. So as I mentioned before, VizBlocks was designed to be really open-ended and customizable and ambiguous. So I think this really enabled it to be seen almost like a construction toolkit. So a sort of blank canvas with particular affordances that supported experimentation to turn it into a new system, which is something we didn't initially foresee when designing VizBlocks. The way that VizBlocks was reimagined was also supported by the fact that Civic Digits and the VizBlocks project both had shared goals. So they were both very much about enabling people who are new to computing to creatively experiment with data. And they both shared this goal of using physical materials to really support people's creativity and experimentation. Looking back at the project, there are some questions about whether VizBlocks was actually the most appropriate interface for making this shift. And actually, there were key areas where the goals of VizBlocks and how the data-driven actor was implemented differed. So, for example, VizBlocks was aimed to be really open-ended in terms of physical configuration, whereas the data-driven actor adopted a sort of fixed physical configuration as a face. VizBlocks had the goal of bringing in multiple data sources, whereas the data-driven actor was mainly used with this idea of facial expression data especially at the start. But what the two kind of projects had in common was that they both focused on using physical materials as a way of supporting making meaning about data and supporting adaptation by users. In this talk, I hope I've highlighted both the incredible value of working with local businesses to give research prototypes a new lease on life, but also some of the practical considerations of what may be required to make this happen. So thank you so much for listening, and please feel welcome to get in touch with myself or my colleagues for any questions or discussion.